Good day to all electricians. This is Engineer Simeon Panenzuela and welcome back to my channel. Our topic for the video today is the single line diagram of 12-story Diamond Hotel. There are two buildings in the hotel. Building A and Building B. This is the single line diagram. The incoming voltage to the hotel is 34.5 kV 3-phase. There are 3 fuse cutouts and 3 lightning arresters on the service pole. We have 2 transformers. Transformer T1 1000 kVA and transformer T2 also 1000 kVA. Inside transformer T1 there are 2 disconnect switches, DS1 and DS2. The disconnect switch DS2 is connected to the second transformer T2. The primary voltage is 34.5 kV and the secondary voltage is 480 Y over 277 volts. We have the metering for the utility and we have the main distribution panel MDPA for building A and we have main distribution panel MDPB for building B. The main breaker of MDPA is 3000 amperes 3-pole 600 volts and the main circuit breaker for MDPB is also 3000 amperes 3-phase 600 volts. And we have a tie breaker which is normally open. If there is no electrical problem on MDPA and also on MDPB, the tie breaker is open. However, if the transformer T1 becomes defective, we can open MCB1 and then the power will come from transformer T2. So this way, going to the bus bar, the tie breaker should be closed and then the power will be distributed to MDPA. However, if transformer T2 is the one that becomes defective, we can open MCB 3000 amperes MCB2 and then close the tie breaker and the power will come from transformer T1. The power will go this way to the bus bar, tie breaker is closed and then the power will be distributed to MDPB. MCB2 should be opened. We have the metering on MDPA and we have the kilowatt meter ammeter, voltmeter with the ammeter switch, voltmeter switch, similar to MDPB. So these are all normal source, normal power. If the utility power has no problem, then all these circuit breakers will be energized from the utility company. However, if the utility company has a brownout, we have a generator, 1000 kVA 3-phase 480Y277. We have the automatic transfer switch and the emergency distribution panel, MDPE. So there's no power on the utility company. We can get power from the generator. We have the metering, voltmeter switch, frequency meter, ammeter transfer switch, kilowatt meter. We have 3 current transformers. The main circuit breaker of the generator is 3000 amperes, 600 volts. So let's now go to the single line diagram of building A. We have a distribution panel DPA. This is 480 volts 3-phase. This supplies power to dry type transformer. The dry type transformer steps down the voltage from 480 volts to 240Y139. So the power of the secondary of the transformer is 3-phase, 230 volts line to line. For every floor, we have lighting panel and power panel. This is for second floor and this is for the third floor. So one dry type transformer supplies power to the lighting and power panel board for 2 floors. So we have this transformer supplies power to second floor and third floor. This dry type transformer supplies power to 4th floor and 5th floor, the normal source. This is for sixth floor and 7th floor. This transformer is for 8th floor and 9th floor. So we have 2 lighting panels per floor. We have 1 lighting panel and 1 power panel for every floor. And the dry type transformer supplies power for every 2 floors. So this one is for 10th floor and 11, and the last is for dry type transformer for 12th floor and the roof deck. So all of this the power comes from MDPA for 80 volts. Now we have the mechanical loads. DPM, distribution panel for mechanical loads. Before we go into that, I would like to review the centralized air conditioning system for the building. The building has a chiller. The chiller, we have the compressor, evaporator, and this one, the chiller, produces the chilled water, which is distributed throughout the building to fan coil units and air handling units. This is called AHU, and the smaller is called the fan coil unit, FCU. The purpose of the AHU and FCU is to collect the heat inside the room. For example, in this hotel, one room will have one AHU, air handling unit. This will have a fan motor which blows the air to the heat exchanger. The cold water is running through these insulated pipes. So this is the supply BI pipe with chilled water. The chilled water goes to the AHU, and the AHU is controlled by thermostat. If the room becomes hot, then the solenoid valve will open and the chilled water will flow to the heat exchanger, and the heat from the room will be absorbed by the chilled water, and it will go back to the chilled water return. This is the chilled water return pipe. So all throughout the building of the hotel, up to the 12th floor, we have air handling units. Now we have the compressor. The compressor is the one that cools, that produces the cooling of the chilled water. This is like the freezer in our house. This one, the compressor, is the one that gives the cooling. We have the refrigerant, and there we have also the evaporator. The heat which returns to the chiller will be transferred to the chilled water that returns to the chiller. Now the water will be further cooled by flowing into the cooling tower. This is the supply pipe, and this is the return pipe. We have a cooling tower fan to give the heat will be distributed outside the building. So we have the return pipe. We have pumps to pump the water to the cooling water. On this side, on the chilled water, we have pumps, chilled water supply pump, and the chilled water return pump. So now we go to the electrical side. We have the DPM distribution panel for mechanical loads. So this is 480 volts. All the motors will be 400, let's say 460 volts because of voltage drop. 460 volts. So we have DPAHU. This is the distribution panel for air handling units. This is for ground floor to 7th floor. We have DPASU. For example, on the 2nd floor, we have distribution panel for all the air handling units in the floor. So it's typical, every floor will have a distribution panel for all the AHU. And this distribution panel for the AHU will supply power to the air handling units, where every room of the hotel will have air handling units. This is the distribution panel for air handling units from 4th floor to 8th floor. And this is the distribution panel from 9th floor up to roof deck. So we have no air conditioning if there is a brownout on the utility company, because the power supply for the mechanical loads will come from the normal power source, which is the MDPA or MDPB. On the ground floor, we have a kitchen and laundry panel board, because the hotel has its own laundry shop. This is the chilled water supply pump and the chilled water return pump. So the power for the chilled water pumps will come from MDPA or MDPB. This is the normal power source. And we have two chillers, chiller 1 and chiller number 2. And we have the compressor. The compressor is controlled by VFD, variable frequency drive. On the basement, we also have a boiler, because we have a laundry, and also we have restaurants, and we have a ballroom on the 2nd floor. We need hot water, so we have a boiler, and the power comes from MDPA and MDPB for building B. Now for the emergency loads. In building A, we have DPE, emergency distribution panel for building for building A. This is supplied from one transformer for 80 volts step down transformer from 80 volts to 240Y139. So this distribution panel is 3-phase 230 volts, and we have the LP auxiliary. So we have the emergency panel. This is for auxiliary systems like Globe Telecom, bldg Telecom, Sky Cable, Cable TV, provider number 2, fire alarm, CCTV, cell phone signal enhancer, ramp traffic lights. So we have another distribution panel for emergency from ground floor to 7th floor. This is lighting panel emergency. And we have another light distribution panel emergency serving the 8th floor to roof deck. So all the emergency panel from 8th floor to roof deck will come from this distribution panel DPE, LP distribution panel. So this is also 240 volts line to line. The voltage is 240 volts line to line, served by one dry type transformer for 80 volts to 240Y139. So we have transfer pumps. These are two duplex pump. This is a duplex pump, and we have a transfer pump distribution panel, control panel for transfer pump. This has wiring connection to the roof deck. This is overhead water tank. We have 3 float switches on the overhead water tank located on the roof deck. This one is the fire pump. We already have a video on the detailed discussion of the fire pump. You can review that video, previous video on the fire pump. And we have also a submersible pump on the basement to avoid flooding. On building B, we have a swimming pool connected to the distribution panel on building B. We also have tennis courts and basketball courts disconnected to distribution panel on building B. So we also have an elevator. This is power panel elevator, and this is connected to emergency panel on MDPE. All the emergency loads are connected to the MDPE and the ATS, so that it will have power during brownout from the generator. So on the roof deck we have also cooling tower fans. This is for the air conditioning. It comes from PPRD, roof deck power panel. We also have booster pumps. We have discussed these booster pumps on a previous video. Please check my previous videos on the administration load of condominium building. Also the pressurization motors for the fire exit. We have also discussed this booster pumps control. We have a video on this previous video. And pressurization fans. We also have a video on this pressurization fan on this previous video on the condominium building administration load. So transfer pump, we also have a video on this transfer pump. Please check out the administration load for the condominium building. This is a previous discussed on our previous video. So the load of building A is almost typical to building B. So the only difference is we have the swimming pool, tennis courts and basketball courts get its power from building B, distribution panel B. We also have a kitchen and laundry. Because the hotel has restaurants, we must have a kitchen and laundry panel board. So we have discussed the single line diagrams of building A and building B. On building A, we have a clubhouse connected to building A. We have a separate panel board for emergency and for the normal power on the clubhouse. So that's all we have to discuss on this video. Thank you for watching our video. Don't forget to like, to share, and to subscribe to my channel. To God be the glory. Thank you for watching. Thanks.